This video is if you missed class or if you missed something in class, you want to go back and get an explanation of it. So areas of regular polygons. First thing we did was try to come up with a formula for a regular pentagon. So what is the area of one of these isosceles triangles? So we just use our triangle formula, which is base times height over 2. But we want to use these letters instead. The base we're going to call S because that's the side length of each side, and it's a regular polygon, so all sides are the same. And then the height is actually this A, so SA. And then we just do divided by 2. So that's the area of one triangle. But how many triangles are there? There are 5. So now we multiply this by 5. But instead of writing 5, we're going to write n, because n represents the number of sides in our formula. Okay, so we get this SAN over 2. And the order of multiplication doesn't matter. So it could be ASN over 2. It could be NAS over 2. However you want to remember those letters in that order. And so this doesn't just work for regular pentagon. It works for anything. And all we need to do is change the number of sides for our formula. And of course, we need to know what A and S are. So let's go on. So if we're generalizing this, the area polygon n sides, so like we just did before. Another way to write this is 1/2 times ASN, or you could just do ASN over 2. And so, I was sort of already explaining this before. If we let S be 5, or if we let n, the number of sides, be 5, 6, and so on, the area of this polygon would be 5 over 2 times AS. This would be 6 over 2 AS. This would be 7 over 2. We're just changing n. Okay, and then so on. This just becomes NAS over 2. And like I said before, the order doesn't matter. So then, what does this A even stand for? You might have been thinking it stands for altitude, because it's the altitude of a triangle, and that's true. But it's also called the apothem of the polygon, because it goes from one of the sides in the midpoint at a right angle to the center of the polygon. And so this is a word I expect you to know. It's pronounced apothem. Okay, an example, going through some examples. Find the area of this regular polygon. And this chapter, they're always going to be regular polygons. This only works if it's a regular polygon, because we can separate it into equal triangles. So I'm going to erase that. That looks terrible. So regular polygon, we just use our formula. I always remember it as ASN over 2 for some reason. So I'm going to do the apothem first, which is 24.9, then multiply times the side length. And then n is how many sides are there. So I have to count. 1, 2, 3, 4, 5, 6, 7. So it's a heptagon. Another way I could give you this problem is just say, instead of having a picture, I could say the word heptagon, and you'd have to know that that's 7 sides. And then we divide this by 2. So do everything on the top first. I mean, if you got a calculator, just do everything on the top first. 24.9 times 24 times 7 is 4183.2, and then just divide that by 2. And you get 209.6. That's, sometimes I might have you round to the nearest whole number or nearest tenth. That's one decimal place. So it just depends. If I don't say what to round to, just write down the decimals. And we would just want to put centimeters squared, of course, because we're talking about area. So example 2. This time we're trying to solve for a, little a, which is the apothem. So if I copy down my formula, ASN over 2, I know the area. So I want to plug that number over here. And then fill in, I don't know A, but I know S is 107.5. And I know N, I can just count it. 1, 2, 3. This is a pentagon. Okay, and then we have this number here. So what should we do first? I would highly recommend just multiplying everything by 2 first, because that will cancel out this 2, and then that will double this number. So 19887.5 times 2, 39775. You could just keep that number in your calculator, because the next thing we're going to do, since this is all multiplication, we can divide these individually. We don't really need to multiply 107.5 times 5. You could, but we could just keep that 39775 in our calculator, divide by 5 first, and then divide by 107.5. And we would get A equals 74, just like that. So let your calculator do the work here. There's no need, like I said, you could multiply 107.5 times 5 if you want, and get 537.5 times A would equal the 39775, and then we'd be dividing by 537.5, and you get the same thing, 74. So whatever you think is easier. Example 3, this time we're trying to find the perimeter. If you see capital P, that's for perimeter. And you just kind of plug in, always going back to this formula, since it's a regular polygon we're dealing with. Looks like an octagon, 8 sides. So we're given the area, plug that in for capital A. We're given the apothem as lowercase a. The side length is not known, so I'm going to leave that there, and then number of sides is 8, and we divide this by 2. So now you might be thinking, well, how do we get P if we don't even have P in this formula? But S is the side length, and S times 8 is equal to P, right? To find the perimeter, we just take the side length and multiply it by how many sides there are. So this S times 8 actually is P. So if we solve for S, we can get the perimeter. So let's just multiply both sides by 2 first, again, like we did in the previous problem. 4940.8 times 2, and you get 9881.6, and now this 2 is gone. So we just have 38.6 times S times 8, and we can, like we did before, divide 9881.6, divide it individually, divide it by 38.6 first, divided by 38.6, and then just keep that number in your calculator. It's 256. Just keep it there, and now just divide by the 8. Okay, and then we would get S. But if we're clever on this, we'd see S is 32, but S is not what we want. Actually, what we want is this previous answer. We want the perimeter, which would be, if the side lengths are all 32 and there's 8 of them, we do 8 times 32, which is the number we already had, was 256. Okay. Go on. That's actually the last one. Thanks for watching.